Hi there, how you guys doing? Just been thinking, I'm wondering how many of you are interested in 3D printing, but you don't know how to approach it. Um, so, kind of a recap. The history of my company that I work for, B&J Specialty, we come from a long background of conventionally manufacturing standard practices that everybody has become accustomed to within the molding industry. Um, we have always looked for technology to be the answer on how we're going to make that next step within our company and how we're going to make that next step to provide a optimal product for our customers. So in the years past, we have always been very interested and always kept an eye on the forefront of technology as far as how we could succeed by using it. So that is what has led us into 3D printing. Now, the exciting part about 3D printing in steel for the molding industry is what you can gain with your cooling. It's also normally it is referred to as conformal cooling. Conformal cooling, basically summed up in layman's terms, is when the cooling line follows the three-dimensional shape of your cavity. So you're able to maintain a basically a parallel distance away from your molding surface with your cooling circuit. Typically, everything was normally done in a straight line fashion, straight drilled holes. You would try to get coolant into a certain area the best you could, uh, but at the end of the day, you just had to live with the fact this is as good as it is going to get. So your cycle times are going to be long for molding a plastic part. Your part defects might be pretty bad due to the inadequate cooling that you're able to provide. So, historically, what customers have done is you start looking at these different materials that have a high thermal conductivity, and that achieves the goal of cooling things better, dissipating the heat better. But then in return, what that does is the longevity of the mold itself is not there because now typically with all types of material that have a high thermal conductivity, the downside is they're soft. So they don't last as long. So you spend more money maintaining and keeping that mold in tip top shape. Now, with 3D printing, I'm able to achieve good conformal cooling strategy across the molding surface, meaning that we can dissipate the heat at a uniform rate across the entire geometry of that molding surface. So many things start to happen. You increase productivity because you're reducing the cycle time because the cooling phase of the cycle when you mold a plastic part could be 60 to 70%, if not more, of the overall cycle. So now we're able to reduce that dramatically and also increase the part quality because now everything is being cooled evenly and you don't have the hot spots uh, creating the bad sink marks and the very dramatic warp that you would normally have. Um, many things start to happen when you're able to have good heat dissipation across your geometry. With 3D printing, this is achievable. And the other good thing is it is a tool steel grade of material. Miraging steel is the name of it, but it is heat treatable. The material specs of it are very, very similar to H13 tool steel. It is you can highly polish it. If something down the road changes, you have to do an engineering change. You can machine it. You can weld it. It's just like a normal piece of tool steel. So if you guys have any questions, I know I kind of threw a lot out there, but feel free to get a hold of me. Again, my name is Jarod Rauch. I work for B&J Specialty. Thank you very much. Have a good day.